You know, we use numbers every single day, right? But have you ever stopped to think that maybe, just maybe, they have a secret life, a whole hidden world of patterns and mysteries that actually shapes our entire universe? Well, today, we're going to pull back that curtain.
And let's kick things off with this incredible thought from Johannes Kepler. For him, math wasn't just a tool for doing calculations, it was the very language of reality, the code of the universe itself. And honestly, that's the perfect way to think about what we're about to explore.
Okay, so here's our roadmap. First, we'll look at the universe's hidden code. Then we'll meet the fundamental building blocks, the primes. After that, we dive into a secret world of number families, uncover some truly strange connections between them, and wrap it all up with the ultimate mystery of what it all means.
First up, the universe's hidden code. I mean, just how deep does this connection go? How much are numbers woven into the fabric of our existence? Well, it turns out they're not just for counting sheep, they are the literal blueprint.
Just think about this for a second. When a little kid is learning to count from 1 to 10, they have no idea. They're also reciting the exact order of the first 10 chemical elements. 1 is hydrogen, 2 is helium, 3 is lithium, all the way up. This simple, perfect order suggests there's this really profound link between basic counting and the very stuff our universe is made of.
All right, so to really start cracking that code, we have to meet the superstars of the number world. The most fundamental, the most important, and definitely the most mysterious of them all, the prime numbers.
Okay, so quick refresher for everybody. A prime number is any number you can only divide by itself and the number 1. That's it. You can think of them as the irreducible atoms of the number world. And every other whole number, well, those are the molecules, all built from these prime atoms.
So here are the first few primes, along with their index, which is really just a fancy word for their position in line. So the first prime is 2, the second is 3, the third is 5, you get the idea. But as you look at this list, there's no obvious rhythm or reason to it. They just seem to show up randomly.
And this, right here, brings us to one of the greatest mysteries in all of mathematics. For literally thousands of years, the absolute greatest minds in history have tried and failed to find one simple formula that can spit out every single prime number. And you know what? No one's ever done it.
So if we can't predict where the next one will be, maybe they just stop, right? Is it possible there's a biggest prime number out there somewhere, a final prime at the very end of the line?
Well, the ancient Greek mathematician Euclid gave us a solid answer. Absolutely not. And the way he proved it is just beautiful. He said, okay, let's just imagine for a second that there is a largest prime. We can take all the primes that exist, multiply them all together, and get this one gigantic number. But what happens if you just add 1 to that number? Well, this new number can't be divided by any of the primes on our original list. So it has to either be a brand new, bigger prime itself, or it's made from new primes we hadn't found yet. Either way, our list was incomplete. There can be no largest prime. They go on forever.
So we know for a fact that primes go on forever. But here's the thing. They're not alone out there. They're part of this rich, complex ecosystem, this whole extended family of numbers.
Right, so if primes are the atoms, then basically all the other whole numbers are composites. These are the molecules made by multiplying those prime atoms together. So the number 6 is just a molecule made of one 2 atom and one 3 atom. Simple as that. Every single number is either a prime atom or a composite molecule. But this is where things start to get really weird. Meet the twin primes. I love these. They're like prime number siblings, pairs of primes that are only separated by one other number, like 17 and 19. They just keep popping up throughout the number line, always hanging out together.
And this leads to another huge mystery. We know primes go on forever, but mathematicians have absolutely no idea if twin primes do. It's one of the most famous unsolved problems in math. Do these prime siblings just stop appearing at some point, or do they also go on forever? Nobody knows for sure.
And the family tree just keeps growing. The source material we're digging into even gives names to the numbers between a twin prime pair, calling them twin prime companions. And a prime that doesn't have a twin, well, that's a lonely prime. These aren't just cute names, you know. They're genuine attempts to classify and understand the hidden structure of this world.
Okay, this is where it gets really fascinating for me. These different families, the primes, the composites, the twins, they don't just exist side by side. They actually interact and connect in these strange, almost spooky ways. So here's the secret sauce.
The key to unlocking these hidden patterns isn't just looking at the numbers themselves. It's about looking at the relationship between a number and its index. Remember, that's its position in the sequence. This is where the magic starts to happen. Take a look at this. It's wild. Sometimes, if you take a prime number and just add its own index number, the result is another, totally new prime number. For instance, the 98th prime is the number 521. If you add 98 plus 521, you get 619, which just so happens to be the 114th prime. Why? It's a complete mystery. It's just a pattern that's there.
And it gets even weirder. Here's another bizarre connection. If you take a composite number and a prime number that have the exact same rank, so their position in their own separate lists, and you add them together, you can get another prime. For example, the third composite number is 8. The third prime is 5. Add them up, and you get 13, which is a prime. This isn't just random chance. It's some kind of hidden rule connecting these different number tribes.
So, we've just had a glimpse into a secret world of numbers, full of hidden families, strange rules, and mysterious relationships. And all of this leads us to the final and biggest question of all. And believe me when I say we have barely scratched the surface. The rabbit hole goes so much deeper. You've got Mersenne primes, which are essential in the search for the largest known primes. You've got perfect numbers, which have fascinated people for centuries. Each of these is its own exotic species with its own bizarre properties, just deepening the mystery.
What this all means is that the world of numbers is not what we thought it was. It's not just a simple, boring line stretching from 1 to infinity. No, it's a rich, complex cosmos with its own laws of physics, its own families, and its own secret relationships that we're still just beginning to discover.
The author whose work we've been exploring today calls this whole complex, interlocking system a form of ultimate mathematics. And the idea here is that this hidden structure isn't some accident, and it's not something humans just invented. It's a fundamental property of reality itself, just sitting there, waiting for us to find it. And that brings us full circle, all the way back to Kepler. If the basic code of our reality, the language of math itself, is filled with this much deep, beautiful, and hidden structure, then what does that say about the universe that this code describes? Now that is a question worth thinking about.